The electrical properties of the solid involves the solid substances can be conducts the electricity, and depending upon this electrical conducting power, the solids are classified into the three types: conductors, insulator, and semiconductor. First is a conductor. The solids have the electrical conductivities in a range 10 raised to 4 to 10 raised to 7 per ohm per meter are called as conductors. They can be conducts the electricity. Second point, metals and electrolytes in ionic, that is the ionic solids, are the examples of the electrical conductors. These electrolytes, ionic solids, in ionic solid conditions, they cannot be conducts the electricity, but in their solutions, they conducts the electricity. Metal conducts electricity by the movement of the electrons, while electrolyte conducts the electricity by the movement of the ions, because when they are dissolved, this electrolyte dissolves in the solution. They forms there is a positively charged cations and negatively charged anions, and due to this generation of the ions, they can be conducts the electricity in a solution. Second is the insulator. Insulator means they does not conduct the electricity. Therefore, the solids have low electrical conductivities in the range 10 raised to minus 20 to 10 raised to minus 10 per ohm per meter are called as a insulator. That is, in this range, they cannot be conducts the electricity, or they cannot be migration of the ions or takes place. The most of the non-metals and the molecular solids belongs to this category. For example, wood, plastic, quartz, etc. Next is a semiconductor. Semiconductors, these are the substances. Their electrical conductivity in the range 10 raised to minus 6 to 10 raised to 4 per ohm per meter are called as a semiconductor. This range is intermediate between these conductors and insulator. The metalloids are silicon, germanium belongs to this category. These are the examples of the semiconductors. Next is the band theory. In this band theory, the electrical conductivities of the solid metals, non-metals, and the metalloids are explained in terms of the band theory, because there are two types of the bands. First is a conduction band and second is a valence band. A band is made up of the closely together electronic energy levels, and the band formation can be correlated to the formation of the molecular orbitals by interaction of atomic orbitals. Atomic orbitals combines together to form the molecular orbitals, and these molecular orbitals to forms there is a bands, separate bands. According to the molecular orbital theory, the interaction of the atomic orbitals combining atoms results in the formation of the equal number of molecular orbitals which spread over the entire molecule. Similarly, to this interaction of energy level of electrons in the closely spaced constituent atoms in a solid results in formation of the bands. That is, these energy levels combines together and forms a broad bands. A band theory considered formation of the two types of the band. First is a conduction band and second is a valence band. And these bands are formed from this atomic orbital. This atomic orbitals forms to the molecular orbitals, and these molecular orbitals form a discrete energy levels, and discrete energy levels to gives separate bands. These bands are called as a first is a conduction band and second is a valence band. Another important concept for the band theory is a band gap. Band gap. Band gap. The energy difference between the valence band and the conduction band is called as a band gap. Size of the band gap decides whether the electrons from the valence band can be promoted to the vacant conduction band or not. When the band gap is too large to promote the electrons from the valence band to the vacant conduction band by the thermal energy is called as a forbidden zone. Means there is a difference between the valence band and conduction band is called as a band gap. The electrons are transferred from the valence band to the conduction band is carried out due to the thermal energy. The thermal energy can be promote the electron from the valence band to the conduction band. Then it is called as a forbidden zone. And when this band gap is smaller, the electrons from the higher energy levels in the valence band can be promoted to the conduction band. Higher energy levels electrons are promoted directly to the conduction band if the band gap is smaller by the absorption of the energy in the form of electromagnetic radiation or thermal energy. There are two types of bands are already studied. The first is a conduction band. This conduction band means the highest energy band containing the electrons in the conduction band. It is formed by interaction of the outermost energy level of closely spaced atoms in the solid. That is, the valence orbitals. They can be combined together. These are the empty orbitals are combined together and forms the conduction band. And when the electrons are promoted to the valence bond to the conduction band, then the electricity is transferred. The conduction band may be partially occupied or vacant. This is already explained. The electrons in the conduction band are mobile and delocalize over the entire solid. And due to this property, they can conduct the electricity. Second is the valence band. This valence band, having the lower energy than the conduction band, is the valence band. The electrons in the valence band are not to free move because they are tightly bound to the respective nuclei. They are tightly bound to the respective nuclei. Hence, when the thermal energy is applied to this valence band electrons, they can be promoted to the conduction band and they conduct the electricity. This thermal energy or the electromagnetic radiations are promoted the electrons from the VB to the CB. Then, the electrical properties of the metallic conductors, insulators, and semiconductors are explained in the terms of the band theory as follows. These electrical properties of the metallic conductor, insulator, and semiconductor is explained on this band theory. Therefore, there is a migration of electrons from the valence band to the conduction band. In case of this conductor, there is a band gap. There is no band gap between the VB and CB, that is valence band and conduction band. In insulator, there is a large band gap because there is a range is 10 raised to minus 20 to 10 raised to minus 10 per ohm per meter their conductivity, and therefore it cannot be there is a electron transfer from the valence band to the conduction band. But in case of the semiconductor, this band gap is moderate in this metallic conductor and insulator. When the temperature increases, then the electrons are transferred from valence band to the conduction band, and therefore at higher temperature semiconductors conducts the electricity, and at lower temperature they cannot be conducts the electricity, they act as a insulator. Hence, this dual property of the insulators as well as the conductors behaves this semiconductor, and this is also called as a metalloids. All these properties, metallic conductor, insulator and semiconductors is studied in deeply in next lecture. Thank you. He lectures this lecture prepare properly, make study accurately with assuming this all these points and purport the perfect points for the examination. Thank you.